Hello, how are you? I'm doing well. This is Rhett Elaine. Okay, so I'm going to go over, this is for the lab class. I'm going to go over, let me move this down a little bit, how to do just a straight, simple calculation with Glowscript. I showed how to do it with a spreadsheet and with VPython, but I'm just going to do a similar thing with Glowscript. So Glowscript is an online editor and it runs everything online. So you just need math. It's called it's called WebGL. I don't know, your browser, if you use Chrome, it'll work. How about that? Okay. The first thing I'm going to do is add up here this line, Glowscript. It starts off Glowscript 1.0. You add in here CoffeeScript, and then you have to refresh the page, and it makes it in CoffeeScript, which is like Python. Okay, that's all that does. Okay, so now I'm just going to go through this as fast as I can. The first thing I'm going to do is this. Scene.autoscale equals false. What this does is when you run the program, it'll zoom in and out to make it take up space, and that's going to make it look weird for you. So I would do this. You don't have to, but I would do this. Now I'm going to do this. Ball equals sphere. That's all I'm going to do. It makes a ball. I'm going to run the program. Hopefully it'll run. Runs in the browser still, and there's my ball. And then I can rotate around. See, I can rotate, zoom in and out. There, it rotated. Okay, and zoom in and out, which for some reason there it goes. So it zooms in and out. Okay, so I can edit this. I can manipulate this 3D environment. So let me go back to edit the program. I want to throw a ball up with an initial velocity of, let's say, I can't remember the value, let's say 3 meters per second. And I want to model that motion. Okay, so the thing I definitely need about this ball is to give it a position. I need to say, where is the ball? So I'm going to say position, and it's a type vector. And let's start it at 0, 0, 0. Okay. I also want to give the size of the ball, which you don't actually need, but I'm going to give the size. And let's say it's a tennis ball. No, that's bigger than that. Let's say it's like a soccer ball. So that'd be like, has a radius of maybe 0.1. So you got to give 3 dimensions here because it doesn't have to be spherical. Oops. Okay. You could give it a color too, but I'm leaving that off. So if you want to just check to make sure things are working, you can run it. And you'll notice that the ball's a lot smaller because of the size I made it. But it doesn't really matter. Let's make it a little bit bigger. Let's make it 0.5. That's a big ball. It's a beach ball. Okay. Now I want to give it an initial velocity. I'll just call that, let's say I'm going to throw it straight up. Okay. So let's just say ball.v is the velocity of the ball. And it's going to be a vector. And it's going to have a vector value of 0, 3.5, 0. Okay, so I threw it up with the initial velocity of 3.5 is the y component of the velocity. Now I need to do some other things. I need the acceleration, which I'll just call g. G, it's also a vector, and it's going to be equal to 0, negative 9.8, 0. Okay, now I need time. Time is 0, and I need the time step. Let's put this at 0.01. So now I'm going to go ahead and run my program. I'm going to say while, I can't remember what I did before. Let's say while t less than 0.5, so half a second. That's the easiest to start with. Now in this loop, I'm going to first say how fast to run the program. This statement right here just says don't do more than 100 calculations a second. Since dt is 0.01, if I do 100 calculations a second, it will run in real time. It's not super important, but that's what we're going to do. So now I need to calculate the new velocity of the ball. So I can say ball.v equals ball.v plus g times dt. Now remember, I already said that g has a negative value in the y direction, so this should be a plus. And this is just the velocity update expression here. It says take the velocity of the ball, add g plus dt, and make it the new velocity of the ball. I also need to find the new position of the ball. So this says the new position of the ball is the old position plus the velocity times dt. Finally, I need to update time. And that's it. Okay. Now, just for fun, let's print the ball's position at the end. So if I undo anything indented is in this loop, anything undented is out of the loop. Okay, so let's run it. So it went pretty fast. It's only half a second, right? So it printed out the position of the ball right there. Okay, we're going to make it better. Let's throw it a little bit faster so it goes up higher. Or no, let's do this. I'm sorry. Let's run this until it gets back down to the ground. So if I change this from t less than or equal to 0 to ball.pos.y is the y component of the ball is greater than or equal to 0. Now I'm going to run it. And it came back up and down. I could say how long does that take and print out the time. And then run it. And then 0.71 seconds. You can print out as many things as you want down there. Now let's do one other thing. Let's make a graph of the ball's position as a function of time. So up here, I'm going to say graph 1 equals a series. And that's it. It's blank. That's my graph, except it's garf. It should be graph, not garf. Graph 1. Okay, so now down here, I'm going to say, in my loop, I'm going to say graph1.plot. And I'm going to give it the x and the y coordinates of my graph. So in the x, or the horizontal, I want to be the time. So it's t. And in the y, I want it to be the position, the y position. So ball.pos.y. Now if I run this, you see it added a graph here, and then it goes up and back down. It starts at 0. It goes a little bit lower because it ran it until it got below that and then stopped. And you can find out how high it went, what time it is, and all that cool stuff. Okay. So there's some things you might want to try playing with. The most important thing, try playing with the velocities and stuff like that, and seeing, because you can compare this to other methods. What happens if I change this to 0.1 seconds for dt? That's a cool thing. Okay, but there's lots of things to play with. I was just getting you started. That should be good for now.